So question 4. In a room at 27 degrees Celsius, a balloon has a volume of 2 liters. What would its volume be in a sauna where the temperature is 47 degrees Celsius? So we're going to go with our same strategy of making a table. And we'll have row 1 and row 2, and we'll leave some space at the top to label these. The first number we come to is 27 degrees Celsius. And what do we immediately do to temperatures? We change them to Kelvin. Okay, Kelvin, 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 Kelvin. Have to use Kelvin in gas law calculations. So we're going to add 273 to that. And that looks like that's going to be 300 Kelvin. And we should have named one of our kids Kelvin. That would have been fun. And then the next number is 2.00 liters. And the next number is 47 degrees Celsius. And when we're reading this, we see that 27 degrees Celsius and 2 liters are mentioned together consecutively as the words go along, right? And then what would be its volume in a sauna? This is implying that something's changing. So it's, just trying to help you understand how to figure out these questions. The other thing is when we come to this 47 degrees Celsius, recognize, oh, we've already got one of those. We already have a temperature. So don't go put it on row 1. We need to stack that up with the other temperature. So we're going to have 47 degrees Celsius down here. And then we have to do the same thing. We have to convert it to Kelvin. And so that's going to be, what, 320 Kelvin? And now I've used all my numbers. And let's see, we should label these. So these are temperatures. Kelvin and degrees Celsius are temperatures. I'll call that column T for temperature. 2.00 liters is a volume. And we see, as normally we will find, there's a blank spot in our table. And so we'll call that V2. Now we need an equation. We need an equation that's got T's and V's with 1's and 2's. And that'll be this guy right here. V1 over T1 equals V2 over T2. V1 over T1 equals V2 over T2. And that equation has a fraction in it. 2 fractions, actually. And if you're really good with algebra, you can rearrange that and just write down the rearranged equation. That's awesome. But I'm going to assume that there's at least a few of you that's not so easy. So when that happens, what we want to do is we want to cross multiply first. So we're going to take V1 times T2. And we're doing this just to get rid of the fraction because the fraction tends to mess people up. So the top of one side times the bottom of the other, and then we take the bottom of the first side, multiply that times the top of the second side. And that's just a mathematician's trick. So we're trying to find V2. So there's V2. Now, without the fractions in there, it's much easier to rearrange. So we look at this and we see, oh, the V2 has a T1 next to it. We need to divide by T1 and get rid of that so we can get V2 all by itself. We do that to one side. We have to be fair and do it to the other side. So now we have our equation is V2 equals V1 T2 over T1. And this is not the only way to get that equation. It's not the only way to do the problem, but it is the way that seems to work the best for beginning chemistry students. And since that's what you are, that's what we're going to do. So now we've got our equation, and we're going to look at the table and plug the numbers in. We see that V1 is 2.00 liters. So we'll put that in there, including the units. And then we're looking for T2. So we go up here, here's the T column. Make sure we get T2, and we're going to use the Kelvin value, 320 kelvins. And that's going to be divided by T1, which is right here, 300 Kelvin. So we've got 2 times 320 divided by 300. And we'll say that's 2.13. The calculator says 2.133 repeating. These temperatures, we were a little sloppy in how we wrote them, as we often are with temperatures. Our original temperatures that were given to the nearest degree, and then when we add 273, we end up with 3 significant figures in both of our temperatures. The volume had 3 significant figures, and so that's why I'm reporting my answer is 2.13 liters.